Hey guys, it's Group 3 and this is our sheet metal project report. Now, as we were talking about this, we realized that in order to answer some of these questions, we're going to need to know more about the product application. But just given the schematics and what we know, despite the open-endedness of this project, we were able to come up with the process for figuring out the steps that we would need to do. First, we're going to identify a material, and that was fairly straightforward. At one point, and we'll talk about this a little bit later on, at one point there's going to be a deep drawing process in order to form that little cup in the corner. And stainless steel has a great average normal anisotropy value on page 409 in the textbook, because it's fairly cheap, stainless steel would probably be a great material to use. Then we're going to roll the sheet metal, and there's a couple things to think about as we do that. Obviously, the direction that we roll the sheet metal is going to determine the strength of any bends that we have, and we've got two bends going in different directions, one along the side here and one along the top here. Now, if we were to roll the sheet metal this way, then this top bend would be stronger than this one on the side, and likewise, this would make this side bend stronger than the top one. Now, if one of these components, one of these edges here, is load-bearing and the other one is there potentially just for stability but isn't really load-bearing, then we would want to roll in the direction that would give the load-bearing side obviously the most strength. On the other hand, if we wanted both sides to be equal, then we could do something like this, where we would roll at an angle to the direction that we're going to cut it in, and that would give both of these folded edges equal strength. Now, as we actually move into the sheet metal forming process itself, our first step is going to be to cut out the big piece that we're going to be using, the bold outline here on the side. And as we did, we had a couple design changes, actually one in particular. We said that as we're going to bend these, it's important to make sure that there aren't any holes near to that bend, because that'll make the bending process difficult. And so you'll notice these little flaps here, these are going to come up eventually, and so we just bumped everything in just a little bit from the side here, so there's a little bit more of a gap along these edges. We think that's important just to make sure that as we bend these, we're not going to run into issues with the holes we've already punched out. Step 2 is obviously to punch out all these little holes here, and as we saw in lecture, we're going to, as we punch these out, just make sure that we vary it up. So maybe we'll punch out one from the bottom, one from the top, then another one from the bottom, then maybe over on the side, and just make sure that we're not punching out holes next to each other simultaneously, because that could weaken the material. Next, or also as we're punching, it's important to think about which side is going to be rough and which side is going to be smooth. And so here you notice that the inside of this bracket is on the bottom. We figure that probably the outside of the bracket is going to be the one that's exposed to users, and we don't want them to cut themselves on rough edges, and so we're just going to be conscientious of which direction that we're punching it from. Obviously, if the outside or the inside edge here, if the inside of the bracket was what a person would be handling, then we would just flip this shearing direction. But we just want to make sure that we are, as we're shearing these holes, we want to be conscious of the edge that's going to form on the far side. Now, after we've made these holes, we're going to use deep drawing, like we mentioned, to form this central indentation here in the corner. And this is where stainless steel is relevant. Again, on page 409 in the textbook, you can see that the average normal anisotropy value is excellent for stainless steel. And again, it's a fairly cheap and abundant material that's fairly strong as well. We think that just without really knowing much about how this product is going to be applied, it's a good value or a good metal to go with. Now, step number 4 is going to be to bend these sides, and because we've bumped these holes back, that's going to be much more straightforward than it was otherwise. And we'll have a little seam here, and so that leads us to the last part, the finishing. We're probably going to have to weld together these two flaps, and we might also need some sort of annealing process in order to maintain the ductility of the material. Again, it depends on the application. It depends on how this is going to be used. Likewise, we might want to polish it down. Now, each of these extra steps adds to the cost and adds to the time, and so in order to really decide on whether or not that's going to be needed, we'll have to figure out whether this is something that a user is going to be in contact with, whether we need it soft, whether we need it ductile, and that's going to depend on how it's used. But given these steps, we think that we can come up with a neat little piece, and so it would be an exciting project. Thanks a lot.